Hey, boys and girls. Today is Wednesday, March 24th, and we are going to be concluding our calendar grid for this month because tomorrow you will start your number corner assessment and hopefully finish it on Friday. If for some reason you need more time, you may have Tuesday the 30th to work on it because we only have one more day of actual activities before we finish our March number corner. So that's today's activities and then one more day of activities because that doesn't really include the 2 days that you're going to be taking your number corner assessment tomorrow and Friday. So we're going to just start with collecting our fraction for today. So you guys get a third. And, looks like I'm on the line. I got to zoom in. Oh, it's right on the line. So I have to spin again. And I got a 12th. So you got a third and I got a 12th. So I'm going to add that here. And then actually, since you are doing your assessment tomorrow, and we're not updating anything tomorrow or Friday, I'm going to go ahead and spin for tomorrow and Friday's number as well, so that by the time Monday comes around, when we conclude our calendar collector and figure out who really won this calendar race, or this fraction race, I should say, we'll have all of the fractions we need. So here's the next roll for you. Yeah, you get a half, and I get 1/6. Yikers. Now I'm not sure who's going to win if I keep getting the smaller fractions. 1/6 is smaller than 1/2, and 1/12 is smaller than 1/3. So we have one more to collect. Maybe Miss Trammell will get some luck with this last one. And so, again, this is our spin for Friday because you'll be taking your test. But on Monday, we'll be going over who won. So yours, 1/3. Mine, 1/6. So it looks like for this round, you guys kept getting the bigger fraction with the exception of the first 2 days. So 1/3 for you. And 1/6 for me. I wonder what that's going to mean, but we're not going to talk about it today. We will save it for Monday, so you'll just have to stay tuned. All right, so we are going to look at our calendar grid, but before we do, I just want to remind you of the function machine. So when you put something or program a function machine, it's going to repeat that over and over and over again. And we kind of figured out what our function was by looking at small numbers and seeing what was similar in all of them. And then that's how we were able to figure out what our function was, or what our program was. So I'm going to be drawing out some models, some representations to help us figure out what's happening. Okay? So we know that it's increasing by 2 every day, so you can probably guess that today's going to be 53, right? But we got to figure out how in the world do we get 53. So I am going to create a chart for us. And in my chart, I'm going to have my input and my output. And we're going to start with small numbers because that's how we were able to figure out what our program was for the first one. So if I were to input a 1, I'm going to get out a 7. So if the program that we have going on right now with our green numbers would have started from the beginning, that means I would have put in a 1 and I would have gotten out a 7. If I were to put in a 2, I would have gotten out, what do you think? Remember, it was adding 2 for every day output. Good, it would be 9. And then if I were to put in 3, it would be 11 because we're still doing that adding 2 ordeal. Now, we need to figure out how in the world can we figure out what the program is. I can look here and I can say maybe it's times 7, but 1 times 7 is 7, but 2 times 7 is not 9. Do you think it has 2 different steps, much like it did the last time? Maybe. So what if it was maybe, let's say, times 6 plus 1? Well, 2 times 6 plus 1 is not 9. What if it was times 5 plus 2? 2 times 5 is not 9. That doesn't work. So we are going to have to use a model. And I'm going to show you the arrangements because the program machine thinks in pictures, but it spits out numbers. So I'm going to show you the first arrangement, the second arrangement, and the third arrangement to match the numbers we have here. And then maybe we can generate an expression. So here, instead of pulling out a tile at a time, I'm going to do what I did last time and draw a box. And this box is going to represent the number 5. Okay? And then I'm going to change my color. I have one here. Just imagine that this is a tile. And then one here. And each of these tiles represent 1. So we have 5 and then 2. So that was for our input. If we input the number 1, we get out 7. Do you see 7? How do we get 7? It's 5 plus 1 plus 1. And that's going to give us 7. Let's look at the second arrangement. Let me get my block of 5 here. I'm actually going to go ahead and start my block of 5 for the third one. And if this is 5, and I know I need 9, how many are going to go on each side here? Good. This time it's going to be 2. So here's 1, and here's 2. And here's 1. And I know this is not perfect, guys, so just bear with me. And here's 2. I have 1, 1, 1, 1. So it looks like when I input 2, I still have my 5, but then I'm adding my input number twice. If I input the number 2, I get 9. 5, 6, 7, 8, 9. So can you guess what the third arrangement is going to look like? This is 5. How many are going to be on each arm? I'm inputting 3. I input 1, 1 is on each. I got 1 arm on each. If I input 2, I get 2 arms on each. If I input 5, I'm going to get, or excuse me, if I input 3, I'm going to get, good, 3 arms on each. So here's my 3 arms. 1. Trying to get them proportional, but it's really hard. 2, 3, and then here's 1, 2, and 3. So what's my equation look like this time? I still have 5, and then I'm adding the 3 from one side and the 3 from the other side. So what do you see is a constant with each of these 3 representations? Right, 5 is a constant. So no matter what I'm doing, I'm always adding 5. So in our program, somewhere it's going to say plus 5. What else are we doing with 5? Right, we have our input number twice each time because on each arm it has the input number. So let's say in stood for our input number. This is what it would look like. 5 plus n plus n, 5 plus n plus n. Oh look, it's the same for all 3 of these, and that's supposed to be an n. These are all supposed to be n's. I know it looks kind of funky. So how many times am I adding the n, which is my input number? 2 times. So I could write, let's make a better n plus n plus 5 as my function, or how can I use a multiplication expression to write the same thing? Good, I could put n times 2 still plus 5. And I put n times 2 in parentheses because that's what we need to do first. Anything in parentheses happens first. If I didn't put it in parentheses, the order of operations luckily would have still remained that we did n times 2 first before plus 5. But just to specify, I'm going to put it in parentheses. So now let's use that knowledge to make some predictions. Since we're not going to talk about calendar grid anymore for the month of March specifically, let me go back to my calendar grid. Today is the 24th, but let's figure out what would it be for the 27th without trying to just add 2 each day. So let's use our equation. If n times 2 plus 5 is going to give us our output, then if my number is 27, what would my output be? Yeah, I gotta do 27 times 2, and then I still have to add 5. So what is 27 times 2? We should know that anything times 2 is double. You just double it. 27 times 2 is 20 plus 20 is 40. 7 plus 7 is 14. So it's 54 plus 5 would give us 59. Let's check it out. That was for the 27. It works. We found out the function. Let's try one more. How about 30? Let's do 30. So that means we would have 30 times 2 plus 5. What's 30 times 2? That's an easy one. 60. And then 60 plus 5 is 65. Let's see if it works. We got it. That is the program for this function machine. So this month with our calendar grid, we worked on patterns. We also learned about function machines. So if you are having some extra time today, there is a workbook page that's called More Functions in your workbook that I would love for you to complete so that I know that you really understand what a function is, especially before you take this test tomorrow and Friday, right? So more functions, fill in the missing numbers. You got to figure out what's happening between the two. Goes from 1 to 7, 2 to 8, and then all the way down to 5 to 11. What could the program be? Looks like each time it's adding 1. And for this one, each time it was adding 2. And look, it just so happens that we were multiplying by 2. And for the other one, when we were adding 3 each day, oops, where is it? Every day we were adding 3. Do you see that? We were adding 3, and I can pull back up this. 4 plus 3 is 7, plus 3 is 10, plus 3 is 13. It just so happened that we ended up multiplying by 3. So let's look at the first one. If I'm adding 1, chances are I'm going to be multiplying my input by 1, and then maybe I'm adding something to that. So 1 times 1 is 1 still. What would I have to add to get 7? Plus 6. Let's see, 2 times 1 is 2 still. Plus 6, is it 8? Yeah, look, we just figured out the program. But I'm not going to write it down because I want to know that you were paying attention and that you can figure out how to write this expression. But think about that for this one. Every time it goes down, it's adding 6. So maybe it's something times 6. Guess you'll have to figure that out. There are 2 pages, so if you can complete both of them, that's great. The second one is a challenge. So before I go, I want to say good luck on your test tomorrow and Friday. I know we've done a lot of learning together since January. Now it's your turn to show me that you have taken responsibility and learned the things that you need to learn. Have a good day. Have a good rest of your week. I'll see you guys back again on Monday. I'll briefly see you tomorrow and Friday just to go over the test, but really I'm going to see you on Monday. So until then,